Hey, what's going on, everyone? Today I'm going to show you how to set up a site-to-site VPN between two Cisco ASAs with both VTIs and certificate-based authentication. Now, in this virtual environment, I have two ASAs, one labeled HQ, the other labeled branch. Both ASAs are running version 9.8.1. I'll be using VTIs as part of the configuration. And the benefits of using VTIs are that it eliminates the need to create crypto maps, crypto AZLs, and NAT exemption rules. When creating the ASA camp and IPsec policies, I'll be using IKE version 2, which supports next generation encryption. I have OpenSSL installed on this Linux box right here, which will be functioning as my CA server, where I'll be issuing certificates to both the HQ and branch ASAs. Now, currently right now, I do not have connectivity between the HQ and branch locations. The connectivity is essentially going to be dependent on the construction of the VPN. So if I try to ping this router right here at 172.20.02 from this machine right here, which I'll do right now, I can see that I do not get any ICMP replies. Okay, but once that VPN is built, that's going to change. Okay. So in order for our OpenSSL CA tool to properly generate certificates, we need to make sure that the names in the OpenSSL config file point to actual files and directories on our Linux machine. So we're going to create a directory called certs that has these files and directories in there. Okay. So go ahead and start by creating that cert directory and move into it, and then create the directories that we need, one for certs, one for private keys, one for certificate sign requests, and one for new certs. We'll also create an index file, and then also a serial file. And basically what the index and serial file do is they just keep track of what certificates have been generated by the CA. Okay, so we'll create our root private key using the gen RSA tool, specifying the encryption, and then outputting that to the directory root CA private, and calling this CA private key.pem, giving a modulus length of 4096 bits. It's going to ask for a password. Okay, and now we can create our root certificate using the rec tool. It's going to be a new request, and because we're using this X509 attribute, it's basically going to create a self-signed certificate for us using the key that we just created and outputting that to this directory right here and calling it cacert.pem. We need to enter in the password that we used when creating the private key, and go ahead and just follow the on-screen prompts and enter in your identity information. Okay. So one thing I actually want to make sure that I'm not sure if I was actually clear on, that's making sure that the name of your private key and the name of your root certificate, that they actually match up with whatever the names are in the OpenSSL configuration file. Because when you start generating certificates or creating certificates, if these names aren't found, then you're going to run into problems. Okay, so we'll go ahead and display that root certificate. We'll be using this in just a moment. Head over to the HQ location, and here we're going to generate our RSA keys. these RSA keys will be used within our trust point. Okay, so we'll give it a label and call it hq.section.local with a modulus length of 2048 bits. Okay, go ahead and create the trust points and give it a name. Include the RSA key pair. Also include the fully qualified domain name, the IP address, the method of enrollment, which I'm going to do by terminal, and then also, just to save some time, I'm going to paste in the subject name. Okay, it's going to be hq.section.local. Okay, so let's take a look at that real quick. Should be 5 things here: the method of enrollment, the fully qualified domain name, your subject name. You can include anything you want in here. You know, your fully qualified domain name, organization, organizational unit, states, country, location, email address, IP addresses, and the key pair. All right, so now we're going to import the root certificate into this HQ ASA. So crypto CA authenticate, and it's HQ, or the name of our trust point. Okay, let's go back over here. We already have it displayed, so we're going to copy it and go ahead and paste that in. Accept it, yes. And now we're going to generate a certificate sign request. So crypto CA and enroll, followed by your trust point name. Include the serial number, no. Display the certificate request, yes. And copy the request. And move over to OpenSSL. Move into the certificate sign request directory, and we'll go ahead and create a file called HQ certificate sign request.pem. Paste this in here and save it. Move back into the CA directory, and now we're going to create a certificate, create the identity certificate. Okay. HQ certificate sign request, so we'll go ahead and output that to directory certs and call it HQ cert.pem. Okay, sign the certificate, yes. Commit, yes. And now we need to display that certificate because we're going to be importing it into the ASA, the headquarters ASA. Okay. So crypto CA imports followed by the trust points, and then certificate, and go ahead and paste that in. Quit, and it's been imported successfully. All right, so now we're just basically going to do the same thing on the branch ASA. Now I already have the trust point configured just to save a little bit of time, but make sure you do generate your RSA keys and include those into your trust point along with the IP address, subject name, fully qualified domain name, and select your method of enrollment. Okay, so crypto, so I'm going to import the root certificate, so crypto CA authenticate, followed by the trust point. All right, copy that root certificate. Okay, yes, accept it. Now let's generate our certificate sign request, crypto CA enroll, and branch section.local. Display or include the serial number, no. Display the request, yes. Copy that request. All right, and we'll move into the certificate sign request directory and create a file called branch certificate sign request.pem. Paste in the request. And then create a certificate out of that request using the CA tool. CA, certificate sign request, and then branch. Okay, and then we're going to output that to the directory certs. We'll call it branch cert.pem. Okay. And now we will display that certificate. So root CA branch. Copy it. Head back over to the branch ASA. And now we're going to import with the crypto CA import, followed by the trust point name, and then certificate. Okay. All right, so that does it basically for importing the certificates into the ASA. Now we can actually start configuring our VPN. So the first thing that I'm going to do is I'm going to configure the connection profile using the tunnel group and specifying the opposite side of the VPN. And also the type of VPN, which is a site-to-site VPN. And we also need to include the method of authentication. In this case, it's going to be certificate-based. So we're going to be using our trust point or the certificate inside that trust point. You also need to specify the remote method of authentication. That's going to be certificate as well. Okay, so we look at that. Tunnel group. All right, the opposite side, type of VPN, method of authentication. Now we will configure the ISACamp policy. All right, and here we're just going to include all the parameters that will be used for negotiation and establishing a secure channel between the VPN peers for communication. So we'll use AES, which is considered to be acceptable. Group, we'll go ahead with next generation Defi element group 20, which is an elliptical curve. All right, we'll go with next generation SHA 512. And then this is optional, but you can include a pseudo-random generator, pseudo-random function, sorry. And this is basically used to construct additional keying material during phase 1. Okay, we can look at that. All right, that looks all right. All right, so now we will we'll configure our IPsec policy, which is just a combination of security protocols and algorithms that define how the appliance will actually protect the data in transit. So using IKV2 and And in IV1, this was called the transform set. Here it's called the proposal. So AES 256 and SHA 512. And we will say protocol, encapsulation, security payload, encryption, we'll use AES, and then for integrity, go with SHA 512. Okay, so let's take a look at that real quick. IPsec, there's our proposal. All right. So because we're going to be using virtual tunnel interfaces, we actually need to create a profile for the virtual tunnel interface. So we'll give this a name called profile 1. And in this profile, we'll include the proposal, which is right here. We'll set perfect forward secrecy to group 20, and this just causes the security appliance to generate a new set of keys that are unrelated to the keys generated during phase 1. We will set the security association lifetime in seconds for 1 day. And then we'll also include the trust points. Okay. And this defines the certificate to be used while initiating the VTI tunnel connection. And then one side of the VPN has to be set to responder. Okay, so we'll just go ahead and set it here. Otherwise, the tunnel interface won't come up. Okay. We can look at that actually real quick. Crypto Ike. No, it's not that one. It's Crypto Ike, Crypto IPsec. All right. So there's our proposal and the profile, perfect forwarding secrecy, security association, responder, trust point. All right, now we'll create the tunnel interface. Oops, wrong one. Tunnel interface, give it a name. Call it tunnel_1. IP address with a 30-bit mask. Because the tunnel essentially is built on top of the physical infrastructure, we need to define the physical endpoints on the other side of the VPN. All right, the tunnel mode, which is IPv4, and then finally include our profile, which we said was profile 1. Okay, now I need to define the path that the traffic should take to the branch location. Okay, so when traffic is essentially initiating from the headquarters to the branch location, we'll want to make sure that that goes over our VPN. So tunnel, and this is the remote location network, and sending that over to the opposite side of the tunnel. Okay. I want to include that tunnel network into my routing protocol. And then also, I'm going to redistribute that static route into OSPF so that all of my OSPF speaking routers will learn the route. And then finally, I need to enable ISACamp on the outside interface, and this will essentially cause the security appliance to listen for UDP traffic on port 500. Okay, so let me make sure. Tunnel group, okay, that looks good. Show run crypto, IPsec, show run crypto, Ike version 2. All right, so just to kind of save yourself some time, you can go ahead and copy these things into Notepad and just leverage a lot of the work that you've already done. So I've already done that, and just to kind of skim over this real quickly, what I'm going to be pasting into the branch location is the connection profile. Make sure your IP addresses are correct. Also the ISACamp policy, the IPsec policy, the profile that's going to be included in the tunnel interface, and there it is right there. Also the route to the headquarters location, that route's going to be redistributed into OSPF. And finally, going to enable that on the outside interface. Okay, so let's go ahead and look at our ISACamp policy. And we can see that it just came up. We'll go with show interface IP brief. We can see that our tunnel is now up. If I go over back to my Linux machine, I can see that now those ICMP messages are reaching the other side or the branch location, and that all that traffic, that ICMP traffic, is being sent over the VPN, and it is all encrypted. Okay, so hopefully that's been helpful, and thanks for watching.